Hey everyone, ever wondered why light bends when it hits water or glass? Today, I'm diving deep into the quantum level magic behind light refraction. So, let's start with the basics. Refraction is when light bends as it passes from one medium to another because its speed changes. But that's the oversimplified macroscopic view. Let's crank it up a notch and get into the quantum electrodynamics, QED, explanation. At the quantum level, refraction isn't just about bending rays, it's about how photons, the tiny particles of light, interact with the quantum fields inside a medium. Picture this. When a photon enters a material like glass or water, it doesn't just slow down like a car hitting mud. Instead, it interacts with the atoms, specifically with the bound electrons. These electrons get briefly excited and then re-emit the photon. This cycle of absorption and re-emission happens over and over again. But here's the kicker. The photon isn't really absorbed and recreated in a way that loses energy, like fluorescence. Instead, the collective polarization of many electrons causes a delayed propagation effect, and the photon's wave function gets phase shifted. This effective delay makes the light seem like it's moving slower in the medium, and when it hits at an angle, its direction changes. That's refraction. Now let's bring Richard Feynman into the mix with his path integral view. Feynman explained that light doesn't just take one path from point A to point B, it takes all possible paths. These paths interfere with each other. When light hits a boundary like air to glass, all those paths mix, and the most probable path is the one that gets refracted following Snell's law. So refraction emerges from the constructive interference of quantum paths. The path where the amplitudes add up the most strongly, the path of least time, is the refracted path. Lastly, let's talk about the refractive index. On a microscopic level, the index of refraction is related to how easily a medium's electron cloud can be polarized by an electric field. Remember, light is just an oscillating electric field. This polarizability causes a phase lag, effectively changing the wavelength and phase velocity of light in the material. So, to sum it all up in quantum terms, light refracts because photons interact with the electron cloud of the material, causing phase shifts and delays in photon propagation. The collective result of these quantum events gives us the direction change we see as refraction. And Feynman's quantum paths show us that the refracted direction is where path amplitudes interfere constructively. Pretty cool, right? If you want a more visual breakdown, let me know in the comments. Thanks for watching, and keep questioning the world around you.